So as we know, we are continuing the valency now. We all know that valency means is the capacity of an element. That is what we can say combining capacity. When it is forming the bond, how many electrons it can donate, or how many electrons it can receive, or how many electrons it can share is only known as its valency. Is it yes or no, guys? Clear? So valency means we can say the combining capacity of an element is called as valency. At least definition, all should know that valency means what we used to say, everybody? Combining capacity of an element is called its valency. So now this valency based upon donating and as well as receiving and based upon sharing, we people will say two types, which we already studied one type in last class. That is what we can say. What is that called as? Everybody? Electrovalency. And the second one is called as, which we are going to study in our today's class, called as what? Covalency. Now, this electrovalency is again two types. Anyone, please? All of you. Electrovalency is again two types. What is that? Positive electrovalency and another one is what?
Negative
electrovalency.
Now, if you have taken positive electrovalency, if any kind of atom donate the electron or lost the electron, we can say it will turns into what, guys? Atom turns into ion. So which ion it will turns? By loss of electron, it will turns into ion. Which ion? Anyone?
Cation.
Cation. That cation only we can say cations, that is called as positive electrovalency. What is that cations we used to say? Positive electrovalency. Same way, if any kind of atom receives electron or accept the electrons, accept or receive, then the atom turns into which ion? Everybody, it turns into anion. So that is what we used to call as, what we used to call negative electrovalency. Is it right or wrong? Everybody? Yes, please. Mr. Gokul,
Yes.
Anushka, that is still here. We all studied in the last class. Now, we have made one example also for this electrovalency. That is what? Sodium and chlorine will react and they will form sodium chloride. So what is the sodium electronic configuration, everybody? 2, 8, 1. So in valence cell, how many electrons are there? Valence cell, 1 electron.
1.
Yes or no? So that is only it will be. So if it wants to become stable in nature, how many electrons it has to be? Everybody? It has to be 8 electrons. Cell. So now if you have taken chlorine, it has already 7 electrons in its valence cell. So to become stable in nature, how many is needed? Everyone? 1 is needed. That is what it is. So 2, 8, 7. So this is what chlorine. So sodium will donate 1 electron and donating it will turns into which ion? Positive ion or negative ion? Everyone? Positive ion. So it will turns into sodium plus, Na plus and Cl. How it will turns, guys? Cl minus. So it will gain the 8 electrons and will turns into minus. That is what you have to remember. So this is what formation of sodium chloride. Now we can say, what is the electrovalency of sodium? Positive or negative? Let it be whatever it is. So what is the electrovalency of sodium? Everybody? Electrovalency of sodium. How much? Here you can see +1 or 1 plus. And what about the chlorine?
1 minus.
-1, sir.
-1. 1 minus. That is what you have to remember. Are you clear, everybody? Chlorine is 1 minus and sodium is 1 plus. That is what we used to call as electrovalency. So electrovalency is coming by gained or lost. If the atom will lose the electron or gain the electrons, that is what we will say it is electrovalency. Why they are doing this process, either gaining or losing, to attain what? To complete its one rule. What is that rule called as? Anybody? To complete its rule called as, to become stable in nature, it has to be how many electrons in its valence shell? Everyone? Yes,
8 electrons.
8 electrons in its valence shell. That is the reason it is either donating the electrons or receiving the electrons. That is what you have to remember. Is it okay, everybody? Yes, please. All
Yes,
of you.
sir.
That is what. Now, let us see now today's class. We are going to study. Next one is covalency. So remember, electrovalency is forming like number of gained or lost by an element in order to complete its octet rule. Now coming to here, covalency. Covalency is forming like what we studied in the last chapter. Covalency is due to sharing of electrons. Means it will form which bond? Anybody can tell? Covalent bond. It will form which bond? They will form covalent bond. Electrovalency will form which bond? Electrovalency will forms, all of you,
Ionic bond.
ionic bonds. These will form the ionic bonds. 10th class chemistry also will be coming. Be careful. And this is covalent bonds. That is what you have to remember it. Everybody. Are you clear? Mr. Omar, late. Mr. Noor, understand Noor? Now covalency means, remember, the number of electrons shared by an atom, and remember this covalency will only be shown by non-metals. I understand everybody? And electrovalency is shown by whom? Electrovalency is shown by both non-metals and metals. Keep it in mind, both metals and non-metals will source electrovalency, and that also metals will source positive electrovalency, non-metals will source, what it will source? Everybody? Yes, please. Negative electrovalency. That is what you have to remember. But if it comes to the covalency, it has been shown only by whom, guys? It will be shown only by whom?
Negative
Please.
electron.
Yes, please. Non-metals alone. So, remember the number of electrons shared by the non-metals. Shared by the non-metals is only called as, we used to call covalency. Okay, somebody call to Arun Kailash. Understand everyone? Nimish, that is what it is. Write the definition. The number of electrons, Rohit, understand Rohit? The number of electrons shared, shared by an atom of a metal or non-metal. Abrami, atom of whom? Atom of a, everybody, atom of a non-metal called its covalency. Covalency. Make it the force which bond will form. Here bracket I have mentioned. What is the bond will form here? Everybody.
Covalent bond.
Covalent bond. The force by which these atoms are held together. These atoms are held together. You have to respond at least in chart. Tejaswini, are you understanding or not? Held together is called covalent bond. So which will shown by whom, guys? Only metals or only non-metals? Covalency. Yes, please.
Non-metals.
Non-metals only. So two non-metals combine together and they will share the electrons takes place, and a result they will form the covalent compounds. That is what used to called as covalent bond. So covalency will form only covalent compounds. All of you should remember that they will form only covalent compounds or covalent molecules. That is also you have to write. When two non-metals combine together, when two non-metals combine together, then sharing of electrons takes place, and as a result covalent compounds are formed. Everyone okay? Yes, please. All of you?
Yes, sir.
Now, let us form the example. Shall we form the example, Mr. Nimish? Johan? Okay. Now, if you have noticed it, example. So, we all knows that. How many of you know oxygen electronic configuration? Let me know. Oxygen electronic configuration. Yes, please. I want to know
Two, sir.
oxygen electronic configuration.
2, sir.
Yes. Oxygen electronic configuration. Tell me, everybody.
2, sir.
First, atomic number, how much oxygen? Oxygen atomic number. Everybody.
8.
8, sir.
8.
8.
Eight, sir.
Others also should know atomic number, at least till 20. Atomic number Z is equals to 8. So electronic configuration K and L. So how much it is? 2,
2,
6.
2, comma.
What is a valence shell? What is a valence shell?
L, sir.
How many electrons are there? 6.
6
6
cells.
Wants
electrons.
to become stable in nature. It needs how many more?
2, sir.
Needs
2, sir.
how many? Need 2 more electrons, 2 more to become stable. To become stable in nature. So that is why one oxygen 2,6, another oxygen also 2,6. So what they will do? They both will combine together and they will form a molecule. That is what? O2 molecule. So that is why whenever we are writing oxygen, we will write O2 or O. What we will write? We will write O2 molecule.
O2.
We'll write always O2 because O is not stable in nature. It is not stable. Why it is not stable? Because it does not have how many electrons? Sanjay? It does not have? Yes, please. 8 electrons in its valence shell. So that is why oxygen atom is not stable. Who is stable? Everybody. Who is stable in
Molecule is
nature? Oxygen molecule. That is why when I will say oxygen gas means it is O2 gas or O gas. Everybody, it is O2 gas. Clear? Now how it will be happening? Observe. So one oxygen molecule. This is the one oxygen molecule. Okay, I'm drawing it. Observe very carefully. A nucleus. Nucleus is having how many protons? Let it be, doesn't matter for us. Protons and neutrons are present inside the nucleus. Yes or no, everyone? Yes, please.
Yes, sir.
That is. Now, K shell. K shell, how many electrons are there? Respond, everybody. K shell, how many electrons are there?
2.
2 electrons. Understanding? K shell 2 electrons. And L shell, how many electrons? Fastly. 1, 2, 3, 4, 5, and 6. Is it S? Yes, please.
Yes,
Now,
sir.
same way, one more oxygen molecule. They both will combine. You can see how they will be forming. So nucleus, and K shell and L shell. So K shell, how many electrons? 2 electrons. L shell, 6 electrons. 3, 4, 5, and 6. Now, this both will combine. Can I draw only outermost cell, L shell alone? Everybody, is it okay, guys? Yes, please.
Yes, sir.
To understand better. So now, observe, they will combine like this. This is what oxygen molecule. So they both will come together. If you want, I will draw that nucleus and K shell. Nucleus and K shell. Is it okay now? Now, observe very carefully. This oxygen molecule will share 2 electrons, and this oxygen molecule also will share 2 electrons. So totally in the junction, this part, you can see that where they are forming the bond, there we will get this oxygen molecule will share 1 pair of electron. This oxygen molecule also will share 1 pair of electron. So now remaining 4 electrons is there in its valence shell. You can check it. And here also remaining 4 is there. Now, have you observed? Check only one circle. If you consider one atom oxygen, now oxygen will feel how many electrons in its valence shell. Check it, everybody. Only one atom. How many it will be having? Everyone, verify.
8, sir.
8. Because it will feel, of course, these 2 electrons belongs to this oxygen, but it will feel like, yes, I have 8 electrons. And this oxygen also will feel like, yes, it has 8 electrons in its valence shell. So both will satisfy by sharing 2 each. That is what. If you look at this atom, it is having 8 electrons in its valence shell. If you look at this atom, it is also having 8 electrons in its valence shell. That is what we can say. This is only called as, what is this called as? Oxygen molecule. Do you understanding, everybody? So, and this is called as, what we used to call shared electrons. How many it is sharing? Oxygen sharing how many electrons? Each one. Sanjay, Tanishka, each oxygen sharing how many electrons to become stable in
2
nature?
electrons.
2 electrons.
2 electrons.
So they will share 2 electrons each, and finally they'll become stable in nature. Is it okay, Mr. Danishkar? Noor, Umar? Yes, please. That is what. So you have to remember here. Yes, Umar, tell me.
Yes, sir.
Clear, Umar?
Yes, sir.
Yeah. So this is how it will be happening. Now, the element which has 4 electrons in its valence shell, you can take, for example, carbon. All of you observe very carefully. You can take carbon. What is the atomic number of carbon? Fastly, everybody. Carbon atomic number. Everyone. Yes, please. Carbon atomic number, Teriya. Carbon atomic
6.
number 6. Electronic configuration. Electronic configuration. Everybody.
2,4.
4. Clear? Now, like these elements, remember the elements which have 4 electrons in its valence shell, the elements which have 4 electrons in its valence shell, they can only share their electrons to complete the octet, and they will form covalent compounds. So due to this reason only, the carbon forms always which compounds? Carbon will form. Which compounds always? Covalent compounds or ionic compounds? Carbon. Everybody.
Covalent.
Covalent compounds. Remember, all of you, the elements who is having 4 in its valence shell, they can only share the electrons to complete the rule. Which rule? Octet rule. So that they will form only covalent compounds. That point also you have to write. Right. The elements which has which have 4 electrons in the valence cell can only share their electrons to complete the octet rule and form covalent compounds. Is it okay, everybody? Yes, please. Due to this reason, carbon forms always what compounds? Omar? Only covalent compounds. That's all it is. Is it clear, everyone? Yes, please. Mitakshri, Rohit.
Yes, sir.
That is what you have to remember. Okay. Next, I want to make you might be noticed in our textbook that valency tabular column. What is the page number? Everybody tell me fastly. See it and tell. Yes, please. What is the page number? The tabular column, electron configuration, 20 elements is there, correct? I told you to study also that. Page number?
51, sir.
51. In that, have you noticed that some elements having valency, last column you see, some elements having valency, two types of two valencies. Have you noticed it? Yes?
Yes, sir.
Yeah, what is the element
Phosphorus.
that is given? Two valencies. All of you, not
Phos-
see it, guys. What is the elements? A variable valency, you are not seeing that. I don't have a book there. That's what I'm asking you people.
What, sir?
What is the element showing the two valencies? Last cell, you can see that.
Sir, phosphorus.
Magnesium.
Magnesium is showing two valencies. My valencies will be having two. You can check it instead of one. So okay, I'll open the soft copy. You people cannot. I don't know what is this. You have to be very active. It is. If I say something, you have to find it fastly. In the tabular column, I am clearly mentioning correct. So the tabular column, you can check it, everybody. I'll show you. So that is what. So now till now, I have two kinds of valencies. Anybody tell me one is one you can check it, electrovalency, and the next one is what? Next one is what? Everybody. Two types of valency I taught you. One is electrovalency and
Covalent valency.
where covalency. Understanding? Now, if you check it here, phosphorus. All of you observe. You might be check other than phosphorus. Here all hydrogen valency is 1. Helium valency is 0. Lithium valency is 1. Beryllium valency is 2. Boron valency is 3. Carbon valency is 4. Nitrogen valency is 3. Oxygen valency is 2. Fluorine valency is 1. Neon valency is 0. Like that we are studying. But if it comes to the phosphorus, have you noticed the valency? What they are saying? Yes, please. It is 3. Yes, please. Phosphorus, what you are seeing? Tell me. All of you.
3,5.
3,5. So, have you noticed that? Now tell me, what is the valency of phosphorus? Is it 3 or 5? We don't know. That is what? Like this valencies we used to call it as variable valencies. What we used to say? Everybody? variable valencies. So many elements will show that. If we'll take sulfur for example, here they have given valency of sulfur. How much valency given, Mr. Noor? 2 it is. So we can make the valency of sulfur is 2 and 4 and even 6 also. So like this, if you have taken copper for example, so we all know copper. What is the symbol of copper? Everyone?
C.
Cu. So copper is having a valency of 1 plus and as well as sometimes 2 plus also. If you have taken iron, iron we all know. What is the symbol of iron? Everybody?
Yeah.
Iron valency is +2 and as well as +3 also. Means sometimes it will donate 2 electrons, sometimes it will donate 3 electrons also. So like this thing we used to call as variable valency. So this is the third type of valency which I am saying you. So that is what we used to call as variable valency. So it has very less importance in class 9th, but class 11th onwards and class 10th also, so many places we will get variable valency for so many elements. So that is why the third kind of element, the third kind of valency which we are going to study is variable valency. Is it okay, guys? Yes, please. Write it. Third one, variable valency. Right. Can you hear me, everybody?
Yes, sir.
Yeah. Right. Though there are two main types of valency, main types of valency. What is the two main types of valency? Anybody? One is covalency, another one is
Covalent valency.
but some elements can also show more than one valency. More than one valency. These elements. So what is the example given variable valency in our book? Phosphorus. Understand?
Phosphorus.
Yeah, the elements can have their valency equal to the number of valence electrons left after subtraction of valence electrons from 8. So if you take copper, what is a variable valency? I have told you. Example, copper. What it is? Copper shows either +1 and as well as +2 plus valency. Clear? Same way if you have taken some non-metals. What is the non-metals they have given in our book? Everybody. Phosphorus. How much is the variable valency? 2, everybody, sorry, not 2. 3,
3,5.
3,5. If you have taken sulfur, what is the variable valency? It can show 2, it can show 4, and even it can show 6 valencies. So this is what it is. So these kind of things we used to call variable valency. Are you clear, Mr. Akilan? I need response because already Harini and Johan is sleeping. I know that. That is the reason. Rohit, are you understand, Rohit? Nimish?
Yes, sir.
Yeah. Make it. Next. Once this variable valency, if you observe, I taught you a thing called as noble gases. Do you remember what do you mean by noble gases? Anybody? Noble gases.
No.
Yes.
Gas stable in nature, sir.
The gases which are unreactive in nature or stable in nature, whose valence electrons? How many valence electrons, Mr. Sanjay, for noble gases? Noble gases. Noble gases, what is the valence electrons? Everybody.
0.
Valence electrons. I'm asking valence electrons, sorry, not valency. Valence electrons.
8, sir.
Yeah.
8, sir.
Except helium, remaining all helium, helium, neon, argon, xenon, sorry, helium, neon, argon, krypton, xenon, radon. Everything they are having how many electrons in its valence cell? 8 electrons in its valence cell. Helium alone having how many? 2.
2, sir.
And itself is only one shell, that is a K shell. That is why it is stable in nature. Yes or no, guys? Yes. So now, this all the things, if you notice it, go to the tabular column and again see. Somewhere you people notice 0. Valency is 0. Have you checked it? Argon. Valency is how much? Check it here. What is the valency of argon? 0. What is the valency of sodium here? Neon. What is the valency of neon? All of you.
0.
Same way. What is the valency of helium? Check it. What is the valency of helium? 0.
0.
So, like these elements, the elements who is having 0 valency are 8 electrons in its valency cell, except which element? Except helium. That valency is called as 0 valency. This is the 4th type of valency. So the elements who has 8 electrons in its valence cell are helium alone. How many electrons? 2 electrons. That is called as 0 valency. Please write it. Abhirami, understand Abhirami? Gokul?
Yes, sir.
That is right. The element,
sir.
the elements which have 8 electrons, 8 electrons in their valence cell, except whom? Everyone, except
Helium.
helium. Helium alone, how many? Only one shell, that cell
2
is
electrons.
okay. Except helium, valence cell have 0 valency and they do not take part in chemical reactions. That is why they are called as what? Everybody. Sanjay, you are also
Noble gas.
sleeping, I think. Sanjay Kanan also. No response. So what is this called as? They are unreactive. So what they will never involve in chemical reactions. That is why they are called as what?
0
Noble
valency.
gas.
Okay. So these are called, now new name also I will say, these are called 0 group elements. Harizeras, do you understand? 0 group elements are the inert gases. Inert gases, stable gases, unreactive gases, everything we used to called as, all are called as the same thing. Okay. Now, these are unreactive in nature. Now you tell me, this, if they are unreactive means, is there existed a single atom or a pair of atoms? Anyone? like a molecule, they will exist as a molecule or they will exist as an individual atom? That is what my question from for you people. Anybody?
Single atom.
Single atom. That is what it is because they are unreactive. That is why they are called as monoatomic form. They always will exist in what form? Everybody? Monoatomic form. Okay, single atom itself. Due to zero valency, the inert gas exists. The inert gases exist as a single atom or monoatomic form. Are you clear, Omar? Suppose if I have taken oxygen O2, helium, hydrogen H2, nitrogen N2, chlorine Cl2, because they all are reactive. Understand, Omar? Okay. But if I have taken noble gases, helium, single atom, neon, single atom, argon, single atom, xenon, single atom, krypton, single atom, radon, single atom, because